Okay, so far we have seen a couple of models of predictive modeling using RapidMiner. However, RapidMiner is really a very strong application, and it keeps updating its component with uh, the need of the market. And I feel it is the time where you can see some of its powerful engines behind the scene. In addition, I will add a couple of infrastructure videos that I have recorded for my data mining course. Feel free to watch those and to maybe utilize the exercises that I prepared for my students. So it's up to you to try them and to see what is behind the scene or under the hood of this very sophisticated engine. Okay, so first of all, I'm gonna do some very simple changes to the marketing campaign model that we used. So this is the exact model that you have used, I used in my videos, and let me run it and just look at the performance that we were able to achieve. So in this model with decision tree model, we were able to get an accuracy of 93.6%. Now, if I change this model, so right click and then replace operator. So as you can see, you have a very different type of other type of models that we didn't touch base on. Uh, from the predictive modeling, I'm gonna go ahead and use the deep learning, which is really a strong algorithm that came to the surface over the last couple of years and became more utilized and more known in predictive modeling, specifically in image recognition in the medicine field. So if you are doing some type of MRI image recognitions, orientations, this is the one you use. Also, because of deep learning, thanks to deep learning, you see now applications are surfing such as Alexa and Siri on your phone, and many more. And the way the use of natural language processing algorithms to predict or to understand what your question is and to give you the correct answer is using deep learning algorithm, which is type of neural network algorithm. So I changed this, and just I want you to see how much the accuracy being changed dramatically. So you have 98.4 now percent, and I did nothing. I didn't tune the operator. Just as you can see, if you're gonna look at the yeses here that this model missed, so from here, as you can see, predicted yes, true yes were those, and from the true yes, six that missed this model. So only missed 6 customers from all this operation over here. But what I want to talk to you about here is something more complicated and more enhanced, which is the following 2, 3 components. And there is another one I added, and you can add more by using what is called the extension and market extension. Okay, so let us start with what is called turbo preparation. So the turbo preparation, this is where when you needed to deal with data that have missing values, or you have inconsistency in your data, some entries like text instead of numbers, this is where automatically RapidMiner will do this on your behalf. And I would advise you to watch the videos that come with it so you can understand how it works. So it does a lot of behind the scene work, like transforming your data, cleansing the data, and maybe generating a new data in it, and also pivoting the data, and sometimes also if you want to do some merging. And many more steps. So please go ahead and use this for you to understand in future how you can really capitalize more with RapidMiner. And I will show you a place in RapidMiner where you can actually do all those video training and get certified from RapidMiner. There is an exam, online exam you do. It's not expensive, and you can get a certificate, many different level certificate from RapidMiner. how RapidMiner. However, the video tutorials and the training, all of them are free. All you have to do is to register on their community platform, in the academy platform, to get access. And you can see them from now if you want, from here. RapidMiner Academy, just access it and see the different type of certificates they have, and also the community. Those are where people post questions about problems they have, and other people will come and answer those. For the tutorial, I will mention this at the end of this video. Now, what I want to really show you is the auto model. So this is a new feature in RapidMiner, which allows you to upload data and tell RapidMiner what kind of analysis you want to do, and then we'll do the, for example, in our case, marketing campaign. We want to find who are those customers that highly likely, with high confidence, they're gonna respond to our next campaign. That's a problem on hand. So what you do, you give it automatically to RapidMiner, and RapidMiner will run all the type of models and compare them and tells you which one works the best for that specific data. I don't want to show you that from the beginning because you will not care for understanding what the model does. So now you understood the meaning a little bit about logistic regression, linear regression. You remembered some of those from your undergrad classes, and from some of those videos I showed you. But now let us see what RapidMiner can do with data that never seen before, and how it's gonna create a model for us without our help. Okay, which is really dangerous, but let us try it. Okay, so first we have to upload the data. I created my repository for this case, which is the marketing campaign over here. So this is the data, which is the past direct marketing campaign. This is my data actually. This is the Excel file. Also, you can feed Excel file, but this is the data I brought into my repository. So I'm gonna say next, and here is gonna ask you what kind of analysis you wanna do. What kind of data mining problem do you have? So in our case, we are trying to predict who will respond in our next campaign. However, there are two other type of analysis you do in data mining. One of them is a clustering, which is more like profiling. And like, for example, Amazon does profiling. It puts similar people purchases together. So when I log in and let's say I purchase a lot of books from Amazon, so my profile will be similar to those clusters of people who purchase books, whereas some other people, maybe they purchase house products, maybe makeup, maybe some other type of products, that they are in a different group. And it's really good algorithm to use to do clustering. And the clustering is known as unsupervised learning, where you don't know the class. Like, what I mean, in the response here, you know, yes, no, which class you are trying to predict. Does the customer gonna respond in the past, or he did not, and we're creating a model accordingly. However, in the clusters, we don't now have a class, and you might have a bunch. Let's say my students, I want to cluster them in similar group and then group them, so I get information about their age, their gender, their hobbies, maybe their background, education, their cities, and then I run a model. I say, hey, cluster those model, but I have to tell the model how many clusters I want. So I will say 5. So it's gonna create 5 labels instead of no and yes 2. We're gonna have cluster 1, cluster 2 to 5. So those are 5 clusters, and this is gonna do some type of cosine similarity metric between those students, and put the ones that are the most similar to each other inside the same cluster, and the ones are far away from that cluster in another cluster, and keep iterating until find the optimal solution to distribute all those people into 5 clusters. Okay. Whereas outlier is also very important. Analysis can be done with outliers. For example, for fraud detection, those are considered outliers. For instance, let's say I did a purchase in Kentucky this morning, and tonight I am in Bulgaria, Sofia. I did a purchase, so my bank automatically will flag that purchase and stop it because it knows that it's outside the normal behavior of me as a customer, so will not let that transaction take place. And that's one of the aspect of outliers. There are many different types of use of outliers detection, but this is one of them. In our case, so let us work here now, go back to our case. I'm going to click on the predict. This is what I am doing, and I have to tell RapidMiner which of those attributes I have here that is going to be my the column that I'm going to predict, which one I'm going to create a model, what is the y. So it's in my case, the y and all the rest are the axis, for my model if it's linear regression. So my y is a response, so that's the one I have to select. So you have to tell it which one. Doesn't know. It could be any one of those. If you are, let's say you are predicting the gender based on all those attributes. Be predicting the age, maybe predicting the usage of mobile. In our case, anyhow, we are using the response. So we're gonna go to next. And now it recognizes that in this data we have, which we had thousands customers, we had 444 of them responded to the previous campaign, and the rest did not. Okay. And now it's asking me from here, which class of those? So this is the class. Okay. That's why it's called prediction or classification. So which one of those is important? Those who did not respond or did respond? RapidMiner doesn't know which one is more important. In our case, yes, the one we are interested in is yes. But in case in your end it came no, so you have to switch them. Okay. Now, also you can map those values. Like if you don't like no and yes, you map the classes and you say the no it did not respond and yes did respond. So just to make it more, readable for non programmer, let's put it this way. I'm not going to do that, but that could be done. Now, what is the cost effect? So this is like the true yes, that from the matrix that we used in this course. Like if you go back to the confusion matrix, so this is where you want the maximum of the all yeses and the maximum of no yeah cases to be the case of the prediction. Okay, so next. You get the option to select the attributes. You might select all of them. However, it noticed RapidMiner some of those having issues with. Okay, it noticed there are some things, I don't know, either correlation between attributes, and that's also known, a lot of contribution between them. Now if you didn't like what it did here and you run the model, as you can see, it canceled the sales of the last 4 weeks. For some reason it didn't select it. Now if you want to select it, you select it. Okay, so we can see here that you want to run it as it found the data, run it. If you don't like it, come back and rerun it and see if the prediction is better. It's up to you. The model type, so automatically, as you can see here, it's gonna run most of them. They're gonna run naive Bayes, probability based model, and many more: logistic regression, decision tree, the deep learning we saw. Let's see if it's gonna do it better than what I did with quick analysis, random forest, some type of decision trees, and the gradient boosted tree. This takes a lot of time usually to do it. Support vector machine, which is really very high for optimizing the model and provide with really high accuracy model for it. Now if there is date, if there's some text, you can really select those. We are not going to do that, but let us start running the model, and will take time based on the complexity of your data. If you have like millions of records, it might take longer time. And as you can see, the fastest one that was able to run was naive Bayes. Quickly it brought it. And now, based on the classification error you want, what kind? If you remember, we looked at the accuracy. So let me keep the accuracy here and make sure the accuracy is the one and is considered instead of the error message. So we can see now, for example, accuracy it's 75% naive Bayes. There's another one here, generalized decision tree, logistic 94, both of them. Deep learning 94% so far here. We got it better. Decision tree. We'll see when the all model finishes what's gonna happen, and we'll see which one is gonna win. So far, if you look at the symbols here, it selected the best performance was generalized linear model. Okay, generalized linear model was the best so far in this data. So let us continue, and we'll see what's gonna happen at the end. I want you to see all the different things that is gonna generate for you, and those changes based on the new models that can be generated. So some of them, the gradient boosted retreat takes time. Support vector machine also takes time usually to finalize the model, and we'll see which one is the best. So as you can see, so far we had about 86 models were running behind the scene. You are seeing some of them, but actually some of them will be in many different levels can be generated, and not only in one level. As long as the circle is running, that means still generating more modules. And you will see all the shards that we were examining in this course revealed for you here at the end. And that's it. So far, that's what produced. So the model, okay, the deep learning, it seems it's giving me price wise, which means that it's related for the runtime. Let's see, deep learning, the runtime here, okay, and in combinations with the accuracy. So where a generalized model also is not bad. Okay, so let's see the rock comparison. See here, you can see now all those rock comparisons provided for you. Okay, so here the overview. So based on the overview here, the winner is generalized linear model. So where is the generalized linear model? Okay, it's here. That's one, the green. So that's one here. That's the one. Okay, what else? You can see the lift chart. So now depends on, this is the naive Bayes. I don't want the naive Bayes, so let me close that. And we notice the generalized lift model is the best. And you want to look at the lift chart. This is the lift chart of that one. Okay, so we know our case, and based on our case, it's telling you that almost the 30% of those customers was 100% accuracy this model can predict, and then with 40% on average you would be 98% accuracy on average. You're gonna see the deep learning. So here's the lift chart. Okay, so this is the deep learning. Okay, very similar. Now let us go back and see if we kept that attribute that it was deleted, remember? And let us go next and run again. We have to rerun it again and see what kind of difference this is gonna make. See how they are changing based on the result, which one is the fastest, the best. Sometimes why the fast is important, because if you're running your model over the internet, you want to predict over the internet instantly, or on your mobile, you want a very fast model. You don't want your model to be slow, so you will lose your customer by the time you predicted who's gonna stay and who's gonna leave. Not in this case, but I'm talking in general. That's why runtime is really important beside the classification error. And let us switch it again to the accuracy level, not the. So you have all this type of the F measure, those different type. I mentioned them briefly in the last lecture, but those are really important, and based on the case on hand, you usually pick. The accuracy is just, a middle point that you can start from. So we'll see. So it increased now. The deep learning became 97.9. Okay. So far, based on adding that attribute, it became deep learning is number one as the best performance, whereas this is the best gain, the value of gain in that model is the best. Okay, and the gain is one of the measurement that you use. So you go back to the last chapter, you will see those values. And again, it's nothing but like if you go back to how the accuracy is calculated based on the recall and precision, it's just another measurement combination of the precision and recall equation. Okay, so random forest, let's see. So the deep learning here it is 98%, you know, it's rounded. This is what we saw actually on our own. So that's what it produced. But however, now you have a really more sophisticated output that you can analyze. So if I based on this model, deep learning is the winner, the best performance achieved by deep learning. So what I can do, I can look at the model. Those are the results that I can take and copy, and if I am doing a research, I can, you know, use it in my add it to my analysis. The simulator is, I'm going to show it to you briefly just a second, and the lift chart, this is what you add. So now you can see that we improved the lift chart a little bit better in those areas, if you noticed. Yeah, so we have almost, you know, we were better here actually at the third bin, but in general as a whole, as an accuracy, it is better. And you can copy and paste those. So this is where it tells you exactly what values really were influencing this model. Okay, and then again, as I said, you can copy and paste that. Now what you would like also, you would like to look at the rock comparison, and in our case here the deep learning is the brown one. So as you can see, the deep learning it didn't the ROC of deep learning, it didn't jump at the beginning at one. It went and then stabilized, you know. In my opinion, it didn't do that well, even though the accuracy is high, you know. But I would rather pick the generalized linear model, see how it is. It's almost at the beginning one. And again, if you remember the comparison between small and big data, you know, if you have a small data, you would rather to have the ROC is jumping at the beginning to the one, where if you have a big data, you would like to have a stabilized, you know, at least to have the consistency after all. So those are the differences in those type of data. Now what you can do actually, just to let you know here, so okay, this is the comparison at the beginning, overview. You can export this. So all what we did here, it can be exported and to a repository. Show you a second, into my repository, and let's say I want to put it the same one I started this project with. Okay, let's say I want to put it here, okay, inside the AMC. I'm gonna give it a name, let's say auto model, and now close. Now I can go to my design view actually, and from here is my okay, I need to refresh this. Configure repository. Okay, sorry, configure, refresh. There we go. And this is the result for the auto model. All the accuracy that I got, everything in it, you can, you know, look at it, and you can, you know, save it as a data. Like, let me show you. I can bring it here and I can look at this data. Okay, so all those results that you saw between comparison between each of those models is here. Okay, so if you are, you know, archiving this research, you can have it in this way. Now what else you can do, The deployment, now this is where the stage, like if you have something running on the web and you are connected to your data on the cloud, you can implement that automatically. So I would recommend you to watch these videos. But of course, this is where company has its own infrastructure, is ready. It's like Best Buy over the web and is sending recommendation or marketing some of their customers. This is where the deployment take place. Okay, there's something else I can do. Yes, here it is here. Save. Yeah, if you want to see the statistic before I save the results. So this is the data that we had. This is the stats for each one of those. So you can, this is the age, the area. You can see now all the histograms of these data, which is cool. In one place, you can see everything and just copy and paste in your report. The weight correlation, weight by correlation, how much important each one of those attributes was for the model, the importance. So as you can see, the email type was really a good predictor to the response of those customers, the type of email category, and who logged in to our website, this company website, the last 4 weeks. It was the second most important, then the 6 weeks, and then the mobile. Okay, so and if you remember the decision tree, when we created a model with decision tree, you saw that the most important, the one that you picked at the beginning, was actually the login 4 weeks. So it makes sense. This is an important model, important for our model. Also, you can see the correlation between all the attributes at once. So it generates that for you also. Okay, and because you have the area is category, as you can see, it did it for you. It did for you. You know how in stats you separate each attribute that is nominal as one, it becomes this one of the independent variable. It does this automatically for you here. Okay, so even the gender, male and female, you will see them all automatically being done this for you. So if you are comparing those coefficients, this is the way you do it. Now I can save the results. Yeah, this is the cool part. Not only I can save the comparison of the accuracy, but also I can save the whole module and the whole analysis. Okay, so here it is in this area. I'm gonna say auto model results. Okay, it's gonna take time. It's gonna save everything, and you will be surprised now to see how much work has been generated behind the scene by RapidMiner to build those modules for you. Okay, now that is saved, let me go to the design, and here it is the result. So let me show you what has been done on our behalf. So all these been generated for us. Okay, and the auto module results are here, so you can see all of them. Open the results, showing result. Oh, it's already in the result. Okay, so if you want, okay, so imagine that you closed, or let me close this one completely. New, yes. Okay, as if it's in new. For some reason it's showing in the results. So let me close and close everything from here, as if I close all my work and then I started over. Okay, okay, and now I want the auto model. Open full result. Okay, auto model loaded from here. Ah, yeah, so still seeing it. That's available and open, that's why. Okay, save the result. Okay, cancel. So let's go back here. So from here, if you wanna, we agreed that the deep learning is our solution that we like the most. So you can look at the process of the deep learning on its own. Here it is. So this is what it did for each one of them, and you can run it on its own. It's gonna run only the deep learning now for you. And you can see from here it's running all these. Okay, and it's generating those. It's showing you the result for each one and what it did in each specific one. And this is the left chart for for the deep learning. Okay, which is cool. This is really amazing. The amount of work, as I said, is done. It's unbelievable behind the scene. Okay, so this is what I wanted you to know about, to be aware of what's new and it's happening now. Okay. So I'm gonna end this video by showing you some tutorials that comes within RapidMiner. So if you go to the help tutorials, you can go inside each one of these and you read and asking you to do what step by step. Okay, so technically those tutorials are coming with a sample and you should see it from your end. For example, he is asking for to retrieve the Titanic training data from under data. This is the training data, okay? And then he's asking you find in the sample. Then next is asking you to link it to the output. Okay, it's giving you step by step how to do it. Next, and run it. So it's very easy, intuitive, and you can learn a lot of things through those tutorials. I advise you to use them. And also I advise you to go to the Academy website to look at the certificate and to look at what kind of opportunities you might have. So here is the academy.rapidminer.com, the website of the uh, certificate. So you can go through each one. Go to the Get Start and then look at the library and look at the certificates and how you can take the exam. There are many different learning paths, so you can consider one of them that you wanna proceed. So you have many different, so you can go through all this. That's it about the certificate. That's it for this video. Thank you for watching.